Welcome everyone. My name is Maciej Ramotowski and this is XDC 2021 workshops. The first topic today will be hostile multi-tenancy on a single commodity GPU. Can it be secure? Led by Demi Obenauer. Demi, the stage is yours.
Hello? Hello? Sorry. Hi. So, is everyone here who's going to be here? Okay, so I guess this is everyone then. Hello, I'm Demi Marie Obenauer, Invisible Things Lab, and I'm here to talk about hostile multi-tenancy on commodity GPUs and to propose.
Demi, I can't hear you.
Oh.
Yes, it's Chromium.
I'm here to talk about enabling secure multi-tenancy on commodity GPUs. So if you look at current multi-tenancy approaches, aka virtualization in a lot of contexts, though it's not always synonymous, for GPUs, they generally have one of a few different properties. Some of them have really large attack surface. That would be stuff like VTG or VirGL/VirtIO. Some of them only support one VM at a time per GPU. That would be PCI pass-through without SRIOV. Some of them require high-end hardware, as in thousands of dollars. That would be SRIOV-based PCI pass-through. There's also Microsoft's GPU PV, but that's proprietary, so it's not suitable for free and open source software. Or there's some combination of the above, and that's kind of annoying. So for what do we need from a good hostile multi-tenancy solution for commodity GPUs? It needs to provide support for games and other GPU-intensive software. It needs to be secure enough to turn it on by default. It needs
Fuck.
Sorry, we have technical issues. Also, Matthew, please be careful about your language. Demi, I can't hear you.
Can you hear me now?
Yes, now everything is great.
Okay. Anyway, none of the existing solutions meet these requirements. And that's really annoying. So So what I'm proposing is a minimal user space graphics driver. Minimal meaning that we keep the amount of privileged code that can directly talk to hardware, to a minimum. And that's important because less code, less attack surface, less likely to have bugs. Usual reasons. Same as the microkernel minimality principle. Why user space? Because you don't have to wait on the kernel to iterate. When you update, you don't have to reboot. If there's a fault and the thing crashes, it just gets restarted by your service manager. And it should expose a well-defined API that's documented, that's transport independent, and that's specified separately from the source code. It should be written in a modern memory-safe language to provide safe abstractions and avoid memory corruption vulnerabilities. In case you're wondering, by the way, if you're going to use formal verification, if you're going to formally verify it, then any language counts as memory safe because formally verified code that doesn't have any bugs will be memory safe. And it should use capabilities for access control. That's what SEL4 uses. That's what a lot of other modern systems use. And it has a lot of advantages. So why minimal? Well, modern GPUs have full virtual memory support. GPU code is restricted by page tables, just like CPU code is. Ideally, we won't need to perform any sort of really complex static analysis of shaders. In practice, there might very well be a lot of caveats there. I don't know if GPU hardware's instruction decoding is robust enough to avoid that. That said, hopefully, if it has to be done, it can at least be simple. This is an area where the hardware experts will have to determine if that hope is actually viable. Why user space? Well, there's a few reasons. We can use modern programming languages such as Rust, because Rust is just an example there. There's no fundamental reason that I just picked Rust because it's one that I like and use, but there's lots of other possibilities. The point is we're not just limited by what's supported in the kernel. We can use the full standard library. Stuff like opening files and map, all that nice stuff just works. We don't have to use special kernel programming paradigms. We can develop faster. There's no need for a reboot to restart the driver. The driver can be sandboxed via an IOMMU, so it can't at least directly compromise the rest of the system. Now, whether or not that protection is actually good depends, but it at least reduces the likelihood of it crashing the system by accident. And if we wanted to, we could embed the driver into a user space program, such as the Wayland compositor. Is that a good idea? Probably not. See minimality earlier, but it's possible, and it's a cute trick. So why a well-defined API? For one, it means that the specification can be separate from the source code. And that's really nice from the point of view of API clients. It means that your API client knows what it should be doing. It means that you can have proper conformance testing. It means that there's less likelihood of bugs on both ends because there's a document that describes what both sides should actually be doing and that tests can be written against. And it should also be transport independent. Clients can communicate over AF Unix if it's, say, in a container or a Flatpak or something. AF VSOC if you're using something like KVM. They could use vChans for Xen. If you're on SEL4, you could use SEL4 IPC, or you could even use a network. Now, that likely be rather tricky because not shared memory, but the point still stands. And it's easier to fuzz by a substantial margin because the fuzzer knows what it should be doing. And why memory safe? This I'm not even going to go into a whole lot of detail about because it's already a very well-known situation. This is just one link on the subject. Why capabilities? There's lots of resources on capability-based access control. I'm not going to go into all of them here. But the point is that a capability, it both designates a resource and it authorizes access. Without an appropriate capability, you can't access the resource. In fact, you can't even express an action that would access the resource. And that's really nice because it avoids all sorts of confused deputy attacks. If I pass if there's no way for me to get a capability to Etsy Shadow, I can't pass some privileged process a capability that says for Etsy Shadow, and therefore I can't trick said privileged process into writing into Etsy Shadow on my behalf. And that's really nice. It's also used by a lot of other systems. It's used by SEL4. It's used by Capsicum for FreeBSD. It's used by Cloud ABI. It's used by the WebAssembly System Interface, WASI. And as I mentioned, it avoids all sorts of confused DEPU bugs, and that's really nice. Finally, let's write this. GPU multi-tenancy should be readily available. Giving VMs, or other untrusted code for that matter, access to hardware-accelerated graphics should be safe. If you're someone like me who relies on sandboxing a lot, whether it be via something like CubesOS or anything else, you shouldn't need to have a completely separate machine for gaming. And it's up to us to make this happen. I can't do it alone. No other one person can do it alone. But I think we can do it together. And I think that we should do it together because the benefits outweigh the effort required. This really is important. So anyway, I guess now it's time to actually start the discussion because this is a workshop and it's a call for discussion and a call for starting an implementation. So what do people think? Hello?
What do you think about capability enforcement? If you have some command stream to the GPU, do you want to reconstruct it based on the driver API or just analyze what client sent and either accept it or reject individual commands?
So that's not something that I've decided upon. That ultimately the final decision on that should probably be made by people who know more about the hardware. My intuition is that the way I would, that said, my opinion is that if a client tries to do something that they're not allowed to, that's a protocol error and they should be disconnected. If so, in the case of the command stream, I think, well, ideally, there wouldn't need to be any parsing of it because that would all be handled in hardware. But I would say that at least as far as instruction by instructions and access, but I don't think, like, I think, let me put it this way. If the client does something it shouldn't, just disconnect it because that's a client bug. Otherwise, I'd say, as far as the details, I don't know whether it would be simpler and have lower attack surface to have the driver reconstruct the stream based on API calls, or whether it would be best for the driver to validate the stream. My intuition is the former, but I'm not certain.
Yes, I'm mostly asking about not what to do when something is not allowed, but how to detect what the client is trying to do. For example, if you design capabilities for I don't know, accessing some memory, specific memory buffers, or maybe even parts of the screen, then how you enforce that the driver really, the client is not using some obscure operation to operate outside of those boundaries.
So my hope is that can be left to GPU side page tables, and that would be enforced by the hardware. Now, whether or not that actually works in practice is another question. As I said, not a hardware expert. So the ideal situation is, say a shader tries to do something it shouldn't. The GPU it can't, because the memory that it's supposed to access isn't mapped into its page tables. And similarly, the Wayland compositor, it can access the frame buffer because the frame buffer is mapped into its page tables. And it's able to get the frame buffer mapped into its page tables because it presented a capability that authorized it to do so. Now, there is the question of, does real hardware work that way? Again, my understanding is that it does. I could be wrong. Obviously, any sort of instructions that could allow the page table-based isolation to be bypassed would need to be disallowed. Does anyone here have more information about that?
Unfortunately, no, not me at least. And I think it a bit amusing that after moving from userland to kernel side, the graphics stacks now moves back to move back to userland, but from the impression I have from other parts of the system, I have the impression that IOMMUs on x86 hardware is still very primitive and not very well supported. But maybe I'm wrong too.
So out of all of this, probably the least important part of it is that it run in user space. I personally am a huge fan of microkernels, where it basically has to run in user space. Ideally, the same driver should be ideally the driver should be written against some sort of API, so that it could be built as, say, a Linux kernel module, a user space process running on SEL4, a kernel driver running on, say, FreeBSD or NetBSD, etc. As I said, the detail, that's not really the point. I think that I'd rather it run in user space. I also would rather stuff like file systems in the network stack be in user space. I do think that I think that being able to run it in user space would be a huge improvement, if nothing else, just for debugging purposes and for development. Even if the architecture of the system that it's going to be used in production requires it to run in the kernel space for some reason or another. Other than that, I'm honestly, and also I'd really rather it not be in C unless formal methods or similar are going to be used to guarantee that it doesn't have any memory corruption vulnerabilities, that's another reason for wanting it to. But that's other than that, I'm not really certain. Like the other stuff is far more important to me. And also, when I say the same driver, I mean same source code, not same binaries. Also, another thing that I hopefully was implicit from the talk and the slides, but that may or may not have actually been in practice. Was that this is not meant to provide an emulated GPU to a guest that appears to be the real thing. The assumption is that one has control of the guests and that one can write PV aware drivers that are aware for the guests that are aware of this and speak the corresponding protocol. Now, it might be possible to emulate the actual hardware in Qemu or similar, but that's not quite in scope for this project. So what else do people...
This is actually, I think, an important design point. What kind of API, on what level this API should be? Should it be specific to the underlying hardware? Like if you have AMD GPUs, should the API be specific to the AMD? Or should it be generic to work with any hardware beneath?
So parts of it are definitely going to have to be GPU specific, because having a shader compiler run in the driver is just a bad idea. So at the very least, that part is going to be GPU specific. My understanding is that lots of other stuff like memory allocations will also wind up being GPU specific. But stuff like say, for instance, the framing protocol, the way serialization is done, serialization of messages and such is done, that part I think can and should be GPU agnostic, simply because it's easier to implement that way, and I don't think it would be a large performance hit at all. I also yes. And the other thing is that there should be that said, like if something can reasonably be abstracted. Okay, let me put it this way. It's not the micro driver's job to abstract over the hardware. It is the job of the client libraries to do so to the extent that is practical and does not cause too much trouble.
Okay, but this way, it means you need a custom driver on the client VM side, driver library or whatever, for each operating system you want to support and for each graphic device you want to support, which makes this really hard to maintain or with sensible hardware support.
Okay.
Right?
So that's a good point. It's one that I haven't actually fully thought through yet. That said, I think it can be avoided. Though, as far as binaries, I think one will probably need something like that. There might be tricks involving WASM and loading code at runtime or something like that. But I think at a source level, it should be possible to split it into a part that is driver dependent, that is host OS, that is guest OS dependent, but not hardware dependent. And that does things like, for the most part, and a part that is guest OS independent but hardware dependent. So the OS dependent part would handle things like registering device files and such like that. And the device dependent part would handle things like command stream processing, just to give an example. And that avoids it. That if that can be done, and I very much think it can, that turns it from an n times n problem at the source code level to an n plus n problem, which is much more manageable.
I'm not saying it's impossible, but I think it will be extremely hard. See that we have currently open source drivers for some NVIDIA cards, some GPU, some AMD cards, some Intel cards, and they share the OS dependent part in form of Linux kernel API, and the hardware dependent part is still a huge product. And I think what you are proposing is doing the same work from scratch for each of those platforms, which I'm not saying it's impossible, but I'm not sure if it's realistically without a lot of funding and a lot of enthusiasts supporting these efforts.
Okay, I'll be honest here. That's the Achilles heel of this proposal. That, in many ways, this is a long shot, because this is what you get when a security person thinks, what should a graphics stack look like? Not what can we do with the building blocks we have today. So in many ways, yes, this has issues in that regard, and that it is far-fetched. That said, it might very well be possible to implement some of these on top of existing components. It won't have as high an assurance. It won't have as good assurance guarantees as if it was designed this way from scratch. But I think it could still be significantly better than what we have today. So for instance, one could write a wrapper for the AMD kernel module that, just to give an example, that did such things like input validation, made sure that you can't pass bad arguments, only exposed the parts that were actually like needed, stuff like that. I think the elephant in the room is going to be NVIDIA, because binary blob, my intuition and my initial reaction is, as far as the answer to that, we don't support that. We only support stuff for which there is good documentation. In practice, that might be a very hard pill to swallow for a lot of people. And so, yeah. That's one of the reasons why this is... I'd love to see this implemented. But it's not going to be easy. I'll put it that way. That said, Gnode did manage to do something similar, at least for one Intel GPU. They managed to write a GPU multiplexer, and I think it was around 15,000 lines of C++. And that's what made me even consider that this was possible, because they did it, or something like it. And I find that very encouraging. NeoBrain, Matthew?
Yes, but I think Intel graphics are not really high performance graphics, and
I know.
Probably much simpler to handle because of much smaller API. But also for avoiding these all problems, I think one of two approaches could be chosen. Of course, the isolation enforcement part needs to be as small and as robust as possible. But then you can probably have some intermediate component that on one side has this talks to this small driver, and on the other side emulate the original graphics, so you can reuse the unmodified drivers. If that would be possible, then we can avoid a lot of this support matrix issues. Another idea is to expose some unified API for independent of the device, but I think that's way harder.
Yeah, I think that is an absolutely awesome approach. I think also, just to be clear, there is one part that I think can and should be reused. One part of existing GPU drivers that can and should be reused without any modifications, and that's the shader compiler. And my understanding is that's a non-insignificant fraction of the work in writing a GPU driver, is the user space shader compiler. Is that accurate?
Probably, but I don't know if the shader compiler has the proper instrumentation to make sure that the address space does not go out of bounds and so on.
Oh, of course not. The shader compiler is considered untrusted here.
Yeah.
It's the point being that it's a substantial piece of chunk that should be able to be reused almost unchanged. I think, the emulation, like emulate an unmodified user, have the emulation done in a non-security critical piece to reduce the support matrix. I think that's a fantastic idea. I am not sure whether it's practical. Because not a hardware expert. I think if it can be done, it'd be a great idea. What do people think?
What what do you think about a drastically different approach to have a actual graphics card to do all the separation and expose different context in form of SRIOV virtual functions? And of course, some graphics are more robust in this and some are less, but this needs some validation, maybe some fuzzing of the GPUs or something like that. But then no untrusted client would have the actual frame buffer access. And you would do composing of the actual video output using some other method like looking glass or something like that. What do you think?
I think that's a great idea if the hardware supports it. The problem is that a lot of hardware doesn't support it. And one of the goals of this is it should work. One of the goals of this is it should support the graphics hardware people already have. I am not aware of consumer cards that actually support SRIOV. I know that Intel cards support some sort of virtualization, but I don't know if they support SRIOV per se. And also basically that. It's that if the hardware supports it, great. And if the implementation is sufficiently robust, but I don't know if the hardware that users actually have meets that criterion. Because one of the goals of this is, basically that.
I think you've seen the demo from Arthur yesterday.
I have.
I'm not sure about specific what other hardware is supported this way, but I think he found a way to enable SRIOV on graphics that some of the vendors did not initially intended to. Which may allow to use this method on more cards that we can right now.
That's a good point. There's two things that make me nervous about it. One is if it requires flashing using special hardware to overwrite the SPI flash. That's not something most people are going to be able to do. It's the kind of thing that most people. It's not something that can be done in pure software, and it's not the kind of thing that you can expect most users to be able to do. Because one of the goals of this is to meet the end users where they are, basically. The other worry I have is that since it's not supported by the vendor, vendors probably won't issue any sort of security errata for it, and it won't be officially security supported. And that makes me nervous. Again, great idea. I think, and just to be clear, I think the libvfio approach is great. I want them to succeed. I 100% support them. I don't see this as competing with that. I see this as complementary to that. Matthew, NeoBrain, what do you think? Because I haven't heard all that much from either of you.
Well, I was wondering if a first step would not just be to implement something that just expose a dump frame buffer to each client, and that the simple API would be get me a frame buffer of this and this dimension, maybe be able to resize it, and then let the application just copy pixels there This is safe. This may be easy to implement, and for many applications, except games and 3D stuff, with nowadays CPUs, the performance may be okay for GUI applications in this kind of simple environment where you limit the number of issues that you have if you start exposing shaders and other kind of accelerations.
That's what CubesRS already does, basically, and we're working on making it faster by trying to reduce the number of copies. The sad truth, though, is that the graphics world is moving in the other direction. GTK4, for instance, has more CSS invalidations than GTK3, and so it's slower in software rendering. Which is unfortunate, but that's the reality. There's ways to work around that with theming, but they come at the cost of worse user experience. And also, users want to play games.
Yes,
they do, and that's what makes this hard. Users want to play games. Graphics Toolkit developers assume that a GPU is present. And so, for instance, with GTK4, again, using it as an example, the two backends it supports are the Cairo backend, which is incredibly slow, and OpenGL and Vulkan. And so if you don't have hardware OpenGL, you fall back to LLVM pipe.
Yes.
There's no renderer that's designed to be fast in software.
Well, as I said earlier, I really don't know current hardware very much, but I really have the impression that without more help from the hardware, without a really working IOMMU or IOSRV, it's really going to be painful to get something that you can trust. From my experience, the hardware is always very, very offers a very wide range of ways to try to overcome the protection that you will try to implement, and basically.
Is that go ahead?
Yeah. Basically, in my mind, when you have access to some part of the hardware, it's basically equivalent to having access to the full features of the hardware. It's really doing a bad job at partitioning things at this level.
So, are you saying that it's possible for a shader to bypass the page tables and access physical memory directly?
I'm not sure, but I would not bet that it's not possible.
Okay, that would be a nasty problem. And also, another approach, by the way, is something like WASM. If something like WASM for the GPU could be implemented, that would be great. But that is, or if there's some sort of reasonably implementable static analysis that can be done on shaders, for instance, if one can enumerate all possible branch targets and require that shader compilers emit any necessary metadata to make this easy. But if the hardware is... Now, I imagine that for at least some hardware like Android, like some mobile GPUs, for instance, I imagine it should be possible simply because user to root on Android is a fiercely defended security boundary. Same for iOS. But again, if the hardware has to, the idea here is the hardware has to at least provide the equivalent of user versus kernel isolation. The idea here is to avoid having to provide the second layer of isolation at what's effectively a hypervisor level.
Yes, for me, this is the difficult part when you look at vulnerabilities like spectrum meltdown and so on from the CPU side. How can we be sure that there are no such kind of things lurking around on the GPU side?
Well, for Spectre,
currently, when you run several applications with access to the GPU, it would be nice to ensure that one application cannot mess with another. Like if you have two applications with both using some 3D acceleration, GPU acceleration, right?
Yes, and my understanding is that current GPU vendors already support this and will and have issued CVEs for when that isolation can be bypassed. So it's not so like that's what makes me so either there's something I'm missing here, which there very well could be because I'm not a hardware expert, but if they did, but I'm not sure what it is, or this should be doable. So if the answer is this can't be done because...
No, I'm not saying that this cannot be done. It's just that I'm not sure it's possible with the current state of the hardware. You may find some difficulties.
Okay, can you?
But
okay, I have a feeling there's some. Okay, gotcha. Okay. Anyway, so that's annoying.
well, the problem is that we probably would need more people who actually have done some low-level hardware work there today, but unfortunately, there is no one, so we don't have much data to.
Yeah, that would be an issue. This is if the hardware can't provide the isolation, can't provide even basic isolation, then the only hope is software fault isolation, and that makes things a lot trickier. That said, if that's actually the case, if it actually can't, then I'd expect to see a bunch of CVEs filed against things like the Intel GPU driver, assuming that people have done the research.
If this starts to be some path that is interesting for people wanting to exploit vulnerabilities and to get into systems, then probably we will see some more research there and probably more CVEs.
Yeah, that's as I said, that is the biggest weaknesses here are the amount of effort required and the assumption that the hardware can provide isolation. My understanding is that the hardware is getting better, and I don't just mean SRIOV, but like other stuff as well.
Yes, hopefully. I think the chip designers, Intel, AMD, and so on, they have discovered that there are all these kinds of hardware level vulnerabilities that are very difficult to fix after the fact, and they will probably be more careful for the next designs. And we can hope that this will also be true for the GPUs and not only for CPUs.
Yeah. Also, the other thing that gives me some degree of confidence is Intel's reaction to the famous GPU leak bug.
Yes, and the other fact is that I know, but even if I don't have details, that on the HPC side, NVIDIA, for example, is investing a lot on virtualizing the GPUs to allow several people to run CUDA jobs in parallel on high-end GPUs, and they will probably also take care about security there. And even if CUDA is not directly a shader for a GPU, it's still the same kind of architectures and
Yeah.
issues. So
I would not, yeah. Also, yes. So the so I guess the question ultimately, I guess the annoying part obviously is that I can come up with ideas, but I'm not an expert on the hardware.
yeah, me neither, unfortunately. So
Yeah. So yeah, from just, I guess this is very much, here's what I'd like to see happen. It's what I hope to see happen. It's what I think should happen, at least eventually. I think the question is, but there is the question of, has its time come yet?
not completely, but many projects like that really takes years to actually come to something that's usable.
Agreed. This is a lot of effort.
And well, I think it's nice to start thinking about it and start telling people that this is something that we need. Generally, I think that the approach of CubeOS is nice and addresses real issues that many people even in corporate security environments don't really take into account. I've seen a few places where people say, well, you need to have two computers, one to work on our main development of secret projects and so on, and you have another system to handle your email, your browsing on the web and so on. But this basically never really works. The people working there cannot figure out how to properly separate between the two computers, and they generally end up with tricks of whatever is left open, USB keys or other stuff to transfer data between the two and breaking the separation.
Yeah, that's what Cubes is meant to avoid the need for. And basic, like, hardware, like, right now, I think the lack of hardware accelerated graphics is one of CubesOS's main weaknesses. I think Spectrum OS does have hardware accelerated graphics, but I think it uses the Virtile Wayland plus VirGL approach, which has the attack surface problem. And Now, I think VirtIO Wayland is actually a decent approach as long as there's some filtering. It's the VirGL that is the annoying part. If there was some sort of core language for GPUs the way WASM is for CPUs, that would make things, I'd be a lot more comfortable with that.
Yes. Really, I just never got why the GPU world is so split in small different components and nothing really standard ever came out. I really don't know exactly why.
I don't know why either. I think that when it comes to one of the things that really, really encourages me is that somehow Microsoft managed to pull off GPU PV. I don't know how they did it. It's proprietary after all, but they did it.
Yes, that's a good sign.
And my understanding is that it meets all the requirements except for being open source. Somehow they did it. And it's a defended security boundary.
Mm-hmm.
I don't know how they did it. I don't know what the attack surface is, but the fact that they did it is really, really encouraging. Because it is meant for this exact use case.
Yes.
And my assumption is if they can do it, then so can we, as in the open source community, given enough time.
Yes. Again, we would need some people more from the hardware and the driver side. So
Yeah.
To get some light on how to proceed from there.
I agree. And I think that somehow something has to change, because right now the trade-off is your choices are slow or secure, and that's really unfortunate. And software rendering is getting effectively deprecated by toolkit vendors.
Yes, I think that's also a bit unfortunate, because even though if they add some value with more pleasing stuff, if the cost is to have to give up on security because it's not fast enough anymore, then it may be a bit useless. We can probably do nice graphics with fewer hardware acceleration.
I think so too. I think that one of the problems is that people just don't consider the no GPU case. One of the GTK develop. Well, actually, I'm not even going to go there because this is something I can discuss, but I'll discuss it in private. But the point being that now, if there was some way to make software rendering faster in a subset of cases that happen to match the ones that actual toolkits rely on, that would be great. But also, there's the issue that making that the things that help software rendering also tend to be things like getting rid of drop shadows and using flat, getting rid of gradients, using flat colors and basically getting rid of a lot of visual cues. And doing so makes the UX people sad.
Well, I'm not sure exactly, but for example, Android went back, and the material look is quite flat and with no shades and not many 3D effects. So this.
What about things like drop shadows, though?
Are there still the drop shadows on Android material look?
I think so.
I'm not sure, but
it's not. It's really, really not something.
It's probably less visible than in previous versions then. Yes.
I'm pulling up a conversation that I had in the past on this subject.
One thing I know is that it's really important to have quick feedback when you are using a tactile screen, because this is what makes the UX more fluid. That whenever you touch the screen and it has an action, that you get some visual feedback quickly. But that feedback doesn't need necessarily to have complicated 3D effects, in my opinion.
So yeah, I think the problem is that even if it could be implemented without relying on that, the toolkit vendors want to rely on it. Because the toolkit design writers aren't worried about software rendering performance.
Yeah, I know, but I don't know if there is an easy way out of this kind of trap. For example,
hence why I proposed seeing if we can make hardware rendering secure.
Yes.
Which is the whole reason for this talk, is can hardware rendering be made secure?
Perfect.
Because if we have to somehow make software rendering fast, that's going to mean a lot of patches to things like GTK, and that's going to mean somehow convincing somebody's going to actually have to maintain it at GTK. Games still won't work. Web GPU still won't work. Firefox just recently got rid of its basic compositor, which was their software renderer, and now they're using WebRender, a software version of WebRender, which is a bit slower, usable but slower. And the trend is towards assuming, and also battery life on mobile is going to be bad with software, is going to be worse with software rendering because it uses more power. And that really sucks. Like, most of the computing power of a modern device is in the GPU. And wasting it and not being able to use it because of security is not a good situation.
Yes. I don't know if a 2D GPU from 20 years ago, built with modern, smaller engraving technologies, would use more power or less power than the current GPUs. And if we could do something like
Who's going to manufacture it, and B, who's
I
going to?
I know that it's a pure dream.
Yeah, it's like, I guess
no one
it's
not doing no one is ever going this way, but still.
Yeah, it's like, from my perspective, we know where the toolkits are going. We know why they're going there.
Yeah.
We know that if we can provide hardware accelerated rendering to users, then them going there will actually be beneficial to them. So I get, this is not an official motto of Cubes by any stretch of the imagination, but it's a motto. It's something I like to use. Security should be no excuse for poor user experience. And not being able to use hardware accelerated rendering is poor user experience.
Yeah, that I agree. But it's still the initial question that you asked: is it possible to actually do the hardware acceleration in a safe way? That's for me, it's still an open question.
I think that's the other question. If not, what do we need from the GPU vendors? What do the GPU vendors need to give us for this to be possible?
Probably they need to give us the API that you were talking about in a way that it's safe, that provides some guarantees that you can completely separate the data from one application from the data of another one, and that whenever there is a violation there, you will get some clear way to handle it, and not just random lockups and other kinds of things that you cannot recover from.
I will also add, at least in the Cubes context, denial of service is a bug. It is not a security vulnerability.
Yeah.
Being able, if untrusted shaders can crash the system, that is bad. It is not necessarily, at least from my perspective. And again, do not consider, this is not an official position of Invisible Things Lab or of the Cubes OS team. This is just my position. From my perspective, if a feature allows, if the impact can be bounded as this can crash the system, it cannot do anything worse, and it is off by default, then being able to use it for something like games might still be a huge improvement over not being able to use it at all.
Yes, that's also more or less the current situation that we have, for example, on OpenBSD, where we port the current DRM stack to the OpenBSD kernel, and we have a number of bugs. And we don't know exactly what are those bugs, otherwise they would be fixed. But most of those bugs have just the effect of completely freezing the GPU, and only a hard reset of the machine is able to unstuck this. This is not really satisfying, but most of the OpenBSD users are happier with that than with the previous situation where we didn't add any kind of 3D acceleration. And
I think that's I think the long-term solution is, I think the mediated pass-through, mediated I/O approach of libvf.io has a lot of advantages as well. I think the key, it has the advantage that from what I can tell, it would be much easier to use in a cloud context. And KubesOS is a lot like a cloud. It's in a lot of ways like a cloud on a little private cloud on your desktop or laptop. And and part of that is the security requirements. If a cloud vendor is willing to run code from completely untrusted, from completely random customers, and trust on something to provide strong isolation, then there's a decent chance that it will be secure enough for Qubes, in my opinion. I think that said, there's other constraints they have that Qubes doesn't have, like having to support proprietary stuff. I think that ultimately this is a really hard problem. I'd like to see it fixed. I think changes in GPUs are going to really help in that direction, but I think there needs to be clear communication with clear information from vendors as to what's supported and what isn't. Is there any chance that you could ask? Do you have any contacts you could ask about this question?
Well, okay, I can try to talk to the people who do the hardware drivers part on OpenBSD. They have some knowledge about all this.
Are you an OpenBSD developer?
Yes,
okay.
I'm one of those.
Oh, nice.
I'm maintaining X.Org on OpenBSD for 20 years or so. Trying to, well, at least trying to get it to build and so that we can ship something that is reusable. Unfortunately, I didn't have much time to actually work on improving X as much as I wanted to.
Maybe it's time to switch to Wayland.
Yeah, but for this we still have some issues, and more on the input side than on the graphics side.
Oh yeah, because you need to put port lib input.
Yes, exactly.
Or switch your kernel API.
Yes, but this is probably going to be even harder because we support architectures that won't really fit in that model and so on. So it's more like porting or rewriting an API compatible lib input, so that we can have what we need. We were in the past. There have been some people who did some very raw prototypes. We just need to find some time to actually invest some more time to make them better and more robust and expose more features. One of the things is that it's quite easy to have, like with the old X.Core input, just a keyboard and a pointer device, where you don't know exactly, you just have 3 buttons and coordinates and no other properties, no gestures, no multi-touch and so on. Then it's quite easy. If you want to have the full game of all the features that current input drivers propose, then it's quite a lot of more work.
Yeah. Okay. We need to talk privately afterwards.
Yeah, maybe.
Looks like maybe we should wrap up, because unless I can get.
Yeah, I think we've said almost all we said for today.
Yeah.
Anyways, it was interesting. Thanks.
It was interesting. How can I contact?
If you want to contact me, you can either contact me by email. I'm putting it in the chat. Hopefully, I will not get more spam than that I already do. If this is public,
Anything email? Do you have like Matrix or IRC or anything for more synchronous?
I'm on the X developers IRC and also on Matrix matrix titanneutral.net.
If you could type that into the chat, that'd be great.
Yeah, just doing 1 second so that I get it correctly. Up. Sorry, I forgot one error. That's the correct one.
I just sent you I'm sending you an invite right now.
Yeah, I'm seeing it.
Did you get it?
Yes. Joining room. It's running.
Okay, so I think we can summarize it, yes?
Yeah, I must admit, I was hoping for a better outcome.
And a bigger audience, maybe. More people for
Yeah.
discussion, yeah. But nonetheless, thanks all for attending, especially Demi for leading this session. And see you soon on the next workshop.
See you.
See you.
Bye. Bye.
Bye. See you. Hello again. We are ready to go with the second workshop of the day. X.Org Security Buff, led by Matthew Herb. Matthew, the stage is yours.
You're muted, I think.
Sorry about that. Thank you. So the goal of this session is to discuss a bit about the organization of the way that we are handling security issues in X.Org. Currently, as I presented it yesterday, we are using the X.Org security mailing list, but maybe this needs to change, or at least to be amended a bit to be more efficient. I have a number of points that I want to try to discuss today. The first one is how to get new people involved with the process of handling new issues. There are a number of issues currently waiting for someone to handle them on the mailing list. And as I said yesterday, waiting too long with embargoed issues is not a very good thing. So since those issues, at least 3 of them are quite easy to handle, I was expecting someone else to be able to handle them, and I didn't do anything. But this really doesn't seem to be a working strategy. So I hope we can find a better one. The second point, we will probably wait a bit to discuss it, because I've asked Benjamin to come here to discuss, but he's currently presenting a talk, and the next talk with Martin is also something he's interested in, and I would have probably listen to that talk too if I would not be there at the same time. But well, I will look at the replay later. So we will wait for Benjamin to discuss those issues. But basically, what I said quickly in the presentation yesterday is that there are some security issues that are already being handled through GitLab private issues, but I'm not sure if currently this is optimal, because I don't really know who has access to the private issues, and for the vendors to prepare patches. I don't know if they have access to the private issues, if they get some notification that there is some security issue that is being tracked as a GitLab private issue, and how the whole process of preparing the security advisory is being worked on these cases. I've just discovered one of those issues being handled this way recently. So, but this was also a source of reflection for me earlier. For X server security issues, for example, we have been discussing patches on the mailing list rather than opening a GitLab issue. And so for the X server maintainer, it's a bit of a problem, because he gets to listen and to get some specific way to test patches, since they cannot be pushed to GitLab. Another thing that I wanted to discuss is if we need to keep the embargo for all the X server security issues, or if there are some categories of issues that can now be considered as not a security issue anymore, and that for which we can tell to people, just open a regular GitLab issue with the bug, and it will be fixed. And probably, if there is a patch available, the patch may be merged even faster than going through the whole security announcement process, because most distributions currently ship X with the X server running without any specific privilege. So it's basically just a bug in an application, and the way for outside attackers to get data to the X server exploiting the bug, in my opinion at least, often really not completely straightforward. And maybe there are cases where we can say that clearly this has no impact on security, except for the few distributions that still ship X privilege, but they should really do something about this. And also, there is some general work that still needs to be done on X, even if X is dying. It's not dead yet, and it's probably going to be around still for at least a couple of years or more. So it would also be great if some people would volunteer, either as some of code projects, or I don't know if you can get some money to sponsorize those developments to enhance things, fix remaining bugs. Maybe I think one of the main things that would help reducing the number of bugs is to actually use XCB to also generate the server side protocol coding and decoding. There are a lot of things to be done there, because the code on the server side is much more different than on the XLib side. And on XLib, it was already quite hard to do the change, but at that time there was a motivated team of people working on that. Nowadays, those people have mostly switched to other tasks, so we cannot count on the original XCB developers to do that. And the same goes for the server side. Most of the people who developed this code on the server side are now gone. So we really need new people. And maybe other ideas. There were a lot of discussions about using Rust. Why not? Maybe we can implement a code generator that generates Rust for the protocol coding and decoding on the server side, and compile this part using Rust. It's going to be even more difficult on some aspects to integrate it in the various distributions, but maybe it's a solution and a way to also attract more people. Coding protocol coders, decoders in Rust may be more attractive than doing it in C. So that's for the ideas. Just I see 2 people following the workshop on Jitsi, but just as follow GTR, maybe you can just tell us who you are and why you are here.
Hey, it's Alan. Been doing this with you for more years than I can keep track of now. And yeah, we need new people. We haven't really been reaching out to get them, but we need to start doing that somehow.
Okay, thanks. So I don't know how to move on from there. Any input? Maybe I should try.
Well, one thing we haven't tried in a very long time is asking new people to join the list and help out.
Yes.
I don't know if we just want to put out a general call to like X.Org Devel, or if we want to try recruiting specific people, but we need new people somehow, and just waiting for them to show up and volunteer isn't working.
Yeah, and I don't know how many people actually attended the talk yesterday and got the message. So yes, maybe we can do a mail on X.Org level asking for help. And as I said, I wonder if moving to GitLab issues to actually report issues would be a good or not, a good move or not.
Yeah.
Maybe you have more information than I do on how.
I know I see the issues when they're reported privately, but I don't know who else does.
Yes, for some of them I even don't see them, and others I can see a few of them, but not all of them. And I know that working with Matt Turner for the last X.Org security, the X servers issues, he told me that he preferred to get the patches by email, that he didn't know really how it works. I don't know if since then he got more information.
Right.
Because that may be a nice way to handle the issue, to just move that to individual project maintainers, and they are responsible for handling this, and maybe we can get some help from Benjamin to set up things so that people packaging binaries for the Linux distributions and for the BSDs and get the information in advance that there is a new release available and that it will be made public at a given date.
So I do see in GitLab that for the X.Org group, I have the level of maintainer where you have developers. That may be why I see more than you do.
Maybe I'm going to reconnect since I cannot hear Denny.
No, it's
Now I hear you.
so. What was I going to say?
Yeah.
Yeah. So what I've noticed is that some of the issues that I've reported haven't been fixed even after they were disclosed publicly. There was a CVE that I found in 2019, I disclosed in 2020.
Yeah.
For local privilege escalation due to spoofing.
Yes, this one is really complex. Keith Packard did propose a patch, but no one really knew how to move forward with this because it introduced a large incompatibility, I think.
I think the best thing to do is to move the socket to a per user location.
Yes, one of my questions was if there are any applications that don't use libx 11 to actually open the socket and that would get into trouble, but I don't know if it's the case or if
Only one I'm aware there. Let's see there. I think there may be a pure Rust client, but that would be easy to patch.
Okay. Well, that's definitely something that needs to be put on somehow back on the table, and that that needs to move forward. One of the issues that, as I said in previous emails to X.Org Security, and also said yesterday, is that I have less and less time to actually work on those aspects, and even just coordinating releases gets a bit difficult for me. But I can try to find ways to slowly move forward. There is also an issue between that it needs coordination between X server and libraries releases, and that needs to be handled correctly by package managers. Because once you have installed a new library that will look for the socket somewhere else, it will fail to connect to the currently running server. Or we need a transition period where the library is looking at both places.
I think. Go ahead.
I was going to say it's also going to cause a problem for anyone who has statically linked libraries, but I'm not sure we can do much about that.
Can we just say we don't support that case?
Certainly for libx 11, if you are purely statically linked, you lose a lot of stuff like input methods and other loadable objects.
Because I think, like when it comes to the spoofing issue, the only other solution I could think of required each client to implement some sort of the server authentication logic based on UIDs.
Right.
And I wasn't really sure if that was viable. So I think moving the socket's probably the best thing to do, but that does mean that there needs to be a place to put it. And given that home directory paths can be very long, that means that /run/user/UID needs to exist. And on OpenBSD, I don't think it does by default.
No, but we can create it. Systems like OpenBSD, except perhaps for the acceptance by other developers, are not that difficult to handle because it's really monolithic. And if we decide to change something, we can change it in the base system and in the X library at the same time. For me, Linux distributions are more difficult because they assemble parts coming from different maintainers and
I think so. A thought I had was ship out a new X server / X display manager / display manager, whatever packages, and also ship out new client libraries and have the package dependencies be such that the new version of the server depends on the new client libraries and vice versa. So upgrading either requires upgrading both.
Yes, but still, if you upgrade the live running system, you will break the libraries. Once they are installed, they cannot connect to the running server anymore.
True, that is true. So I guess for system control restart display manager.service or whatever it is in a post install script.
Some distributions have moved to a Windows-like upgrade system where the upgrades are only installed part of a shutdown and reboot process.
Yeah.
On Solaris with the boot environment, so it's not an issue. You upgrade another.
Yeah, but otherwise, I think the best thing that could be done is just restart X in the post inst scripts.
Right. Yeah, on Solaris, we just force it to happen in a new boot environment, and then it'll come up after you reboot anyway. It won't affect the running system.
Yeah. For Fedora, I think, tries to use offline updates. I have very little experience with them because in CubesOS they don't work for various Cube-specific reasons. So, other than...
Sorry.
Yeah. Yeah, so what was I thinking? But yes, I think the best thing to do is just restart the X server once the upgrade is completed. That'll terminate that'll cause X clients to terminate, and when the user restarts them, they'll come up with the fixed libraries will be working. Thoughts?
It's not something we can truly control from the X.Org side. We can just advise the distros on how to package it, but
like I think that's like the only reasonable option from what I can tell, because an incompatible change has to be made.
Yes, at least since the issue is already public, and this is the kind of things where we can discuss patches publicly on the X server GitLab and the libx11 GitLab, and publish a branch or something with the code so that people can actually try it and figure out the best way to integrate the updates on distributions.
Wait, actually, better idea.
Yes.
Have it so if changing the format of, so one of the patches that I think Alan Coopersmith has proposed is to allow specifying an absolute path to the socket. So that change on the client is backwards compatible. So upgrade the client libraries, and then change the display. Then upgrade the display manager so that the display manager puts the new socket in the new path, and then a while later, change the meaning of :0 and such.
I don't remember writing that patch. That must have been one of Keith's proposals, but
Or maybe, I forget if it was you or Keith Packard.
yeah.
Sorry,
It's
but
okay.
it is on GitLab. Also, abstract socket support on Linux on the client needs to go. I have a MR for that because those are fundamentally unauthenticatable. Can that be reviewed?
Probably. As I said, the advantage of this is that since it's already public, it's not really X.Org security only problem.
Okay, yeah.
I think
Unfortunately, it falls into the other problem X has, which is that there's just no one reviewing stuff and the X server gets attention, but the rest of the apps and libraries really don't.
Yeah. But at least if we tell people, well, this change to the X server also requires a change to the X11 lib, and then people and XCB, and then people will at least, if they want to test it, they will be required to also fetch the branches from X11 and XCB and test those.
And yeah,
Okay.
I don't know how many people have notifications turned on to know that there's a patch for this waiting out in libxtrans. We may just need to start poking people on the X.Org Devel IRC or mailing list to say, hey, this is in GitLab to be reviewed.
Yes, that's the role that I was thinking about for us, is just to
could X.Org security unilaterally merge the patch?
The list.
No, like
I mean, I can. I have powers to merge patches in any of the X components. Matthew should.
Yes. But normally for the X server, there is a maintainer, and the merge should go through the maintainer.
Okay.
I've been reluctant to merge that patch because I don't work on a Linux distro. It doesn't affect me. I can't test it. Yeah, I can merge it and see if anyone complains. I was hoping someone like Ajax, who works on a Linux, would take a look at it. But
I think
there's a certain point, it's been out there for almost a year now.
I think it's probably just best to go ahead and merge it and see if anyone complains.
Yeah.
I mean, at the very least, it shouldn't cause regressions. And the abstract sockets patch that I put out should be similar. I don't think it should cause any regressions in practice because all the servers also list on the named socket.
Yes, I don't remember when this was added, if it was for some system D integration.
No.
Or if it's just someone who said, well, we have this abstract socket, why not support them in X? I don't remember.
I think it theoretically it could cause some sort of issues with certain container setups. That's the main catch, but given that
I thought it was just someone who was trying to avoid, writing a socket in temp is insecure. It'll be less of a problem if we use this abstract namespace instead, without realizing that it caused other issues instead.
Like I think it's probably just I think it's just best to go ahead and merge it and see if anyone complains, because I don't know. But then I'm also known for someone who is very heavy on C and I at the expense of A. So that's me saying I have my own biases.
Right.
So, but like, I think it's probably best to, I don't know. Maybe let's talk about this later because it's not. I don't know. I'm sorry.
Yes. So this is one issue that, well, we should move forward, but there is nothing blocking. The other issue that you mentioned yesterday, so they are also almost public now, are the issues in the XCB client side. I also told that just before releasing the last libx 11 patches, is that I wrote patches for libx 11, but I saw that clearly the same kind of issues were existing in libxcb. And for this, I don't know how to move forward. If someone has ideas on how to patch the code generator to add more checks there, or if we need to dive into this code to figure it out by ourselves.
As far as the existing code generator in Python, I don't have any. I'm not sure. However, I do know there is X11RB, which is X11 Rust bindings, and it does generate, and the code it generates does have those checks. Now that code is obviously in Rust, but I think it could, even if libxcb can't include Rust components, I imagine that the generator could be, like the logic in the generator could still be used. And also, I'm not sure if a build time dependency on Rust is okay, then the generator could be ported to generate C code. But if not, then the logic should be a good idea of how to do this.
I think the way to go is to first try to manually patch the generated C code to see what needs to be changed to the generated code, and then figure out where in the
Okay.
this
I think, yeah.
I'm not a professional Python developer, but I think I know enough of Python to figure out how to modify the generator once I know exactly where the extra checks should be added. And for this,
Okay.
Someone should look at the generated C code. Normally,
I have an idea of one way to fix the generated C code. There's obviously several.
Okay, I've not looked at it, but normally, as far as I remember, one of the goals of XCB generator was to produce somehow readable code. So it should be.
Yeah, It
should be possible to actually figure out how to patch the generated code on an example, and then retro-engineer that into the generator.
My idea was to basically generate checked versions of the size of functions and the iterator routines that take a length argument and return an error if there's not enough space in the buffer. Actually, probably instead of a length argument, it'd be better for them to take an end pointer.
I'm trying to write down what we are saying.
And also, there's some changes that need to be made in libxcb and like libxcb itself, like the C parts. But those are much easier.
Yes.
And there's a change needed to add a check to make sure that at the very least the server sent enough bytes to fill the reply struct. But that's easy change to make in the generator, and I've already done it.
Okay.
So I can help with that. If you can deal with the hard part is fixing up the generator, but I can show you how to. I
Yes.
can come up with ideas for what the generated code should look like.
Yes, I think that if we have that, then it's probably not that hard to fix the generator.
Okay.
So I just wanted to check where the other talks are. Okay, Benjamin is finishing his talk, and then there is still the talk by Martin. So I don't know if anyone, Demi or someone else, is motivated by trying to also start working on converting the X server side to generated code.
I would be. It's something that I would find personally very interesting. It is not something that I am at all likely to have time for because my time is
that's
basically taken by Cube's work. I think obviously fixing the security issues on the client side is a prerequisite to using it on the server side, because otherwise we would have a security regression. I think.
We have a Nix server release coming soonish. This one is not going to be fixed for this, and I don't even know if the pending issues that were reported is going to be part of this release or if it's going to be a separate release.
I think
that it would be switching to generated code would definitely close this kind of issues, and then the server could mostly be considered as complete from the security point of view, because we got rid of most of the font parsing issues, since everything is done by free type, so this is outside of our scope.
Is there a way we can turn on? Can some features of X just be turned off by default? I'm thinking specifically byte swapped clients, maybe even parts of the core protocol nobody uses.
Well, that's a good question. It's true that since most of the clients are local nowadays, all the swapping code is mostly unused.
Yeah, I have been wondering about just turning off byte swapping support if you're running on local sockets only, because technically you can still enable it if you write a custom client to go into via the swapped paths.
Are there?
There's no real reason you should be able to. It's there, you can, but why?
I seem to remember there was something about PowerPC or Power which had something. It was some sort of bi-endian processor.
Yes,
I know there have been processors where you can choose the endian depending on which OS you're running, but I don't remember any that let you switch on that have some applications running big endian and some small.
I think there was something with KV, somebody was running. I don't know. I just remember seeing a bug report about that because someone pointed me to it.
I think it certainly seems like something we could turn off by default, and if you're running on a bi-endian PowerPC platform, well, then you have to compile it in.
Yeah, maybe at the time where Apple switched from PowerPC to Intel.
I know what it was.
The emulator was probably running Intel and Little Indian and PowerPC code and Big Indian.
Yeah, that would make sense if you're running an emulated PowerPC client on an x86 processor. Or
I think this particular one was actually whatchamacallit. Oh yeah, I think this had something to do with KVM. I think somebody was running a little Indian or a big Indian KVM guest on a little Indian host or vice versa or something on power. And somehow they got shim working because the bug was that byte swapping in MIT SHM didn't work or something like that.
I mean, I know on Solaris, our builds would leave the byte swapping support enabled because we have a lot of, our customers, they'll try to run a Spark application displayed remotely to an x86 desktop or laptop, and we get bug reports on that. But
also,
that's not the case for 90% of Linux users.
Oh, also, the other thing is, even if it's compiled in, I imagine it would be very easy to turn it off, make it controlled by a flag at runtime.
Yeah.
I mean, just like was done with GLX, if I remember correctly.
Yeah, as you say,
GLX indirect.
If the code is implemented correctly, which is always a big if in the X server, then it should be a simple check to reject selecting the big Indian. The Indian swapping mode is done in the connection setup code. So just a simple check there to say, oh, if you request Indian swapping, we just say no, you're not going to connect. Should be simple.
Yeah. Also, I have some. As far as other improvements, I have a documentation MR improvement for XCB. And what was it? Oh yeah.
And yeah, you've just seen that in general, there's few people reviewing XCB MRs since.
Oh yeah, and also this was an XCB Proto one, right. But also the extended SHMs attach MR and the server termination extension.
Yeah, I've not followed that too closely, but yes.
Ironically, the original authors of XCB are all off doing Rust stuff now instead.
I find that hilarious, but awesome. I mean, using Rust, I think probably from my perspective, probably the single biggest, one of the really awesome improvement for X would be sandboxed X Wayland. And by that, I mean that if you have something like Flatpak, have X Wayland run in the context of the Flatpak sandbox, and the compositor connects to each X Wayland compositor connects to each X Wayland instance separately. And that way, Flatpaks that rely on X11 can do so without losing sandboxing.
Yeah, honestly, I don't know enough about X Wayland to actually see what would be involved to do that, but from the few things that I know about it, it looks like it's possible, but well. So I see that Benjamin joined. I don't know if you are available or if you are still listening to Martin talks.
I'm trying to do both, but I guess it would be hard to follow both at the same time.
No, but then we will let you finish listening Martin talks. And we
Well, I'll be able to look at recording later if need be.
can,
So
because it really looks like we need to discuss about how the private issues in GitLab are handled when it's security issues. Is it possible to get up to the security advisory and to get a CVID and all this through the private issues, or if we need some mechanism to bridge between both?
okay. Not sure I have the answers for that, but can try to.
No, but there are a few things. For example, I don't know who exactly has access to private issues currently. It's all the X.Org organization members, or it's final grain?
It depends on the project you're looking at. I don't know exactly. I think private issues are probably they're at least for the maintainers of the projects. Well, sysadmins are separate bits because so whenever somebody has sysadmin power, we can see anything on the cluster on the GitLab server, which means that even if I'm not part of the security advisory team, I would have access to those. Private issues.
Oh, the mailing list, basically.
Yeah, that would be the same. Regarding private issues, I think they're at least for the maintainers, but they should be. I'm not sure if it's for. Let me try to open it to create a new issue, because I'm pretty sure that there is a. So they say that this issue is confidential and should be only visible to team members with at least reporter access. So that means that anybody who is a developer and is a reporter would have access to the issue.
Okay, so it's quite wide.
So reporter is anyone who can file a bug. So anyone.
No, reporters is something in the middle.
Okay.
I think reporter doesn't matter much in a public project because, of course, you can file bugs whenever you want. But if it's a private project, then you can have reporters who have access to the project, can pull the project, but they cannot participate in the project like a developer can. I think that's the difference. However, what you can do and what we do within Red Hat for this kind of stuff is you can always have a separate group for the security advisory board, and we can request people to open issues there and have only a few set of people to have access to those issues. It's maybe not the best, but at least that would give you a private space where you can actually discuss with people without having to rely on a mailing list.
Yeah, for me, one of the issues is to get a way to have the binary distribution maintainers aware of the security issues and to get them access to the patches. And so if we switch to
Testing.
Yes.
Can people hear me?
Yes.
Okay, just checking.
For me, one of the questions is if we continue using email-based workflow for the patches and to test the patches, or if it's possible to switch to actually create some private branches and have the patches there, and that at some point just merge the private branch to the main branch and do the release when the bug goes public. And if so, how to give package maintainers the access to the private branch so that they can prepare the binary packages in advance? Because I think that currently this is what they are doing, but I don't really know. having never worked with Canonical or Red Hat or anyone on those. For the OpenBSD side, I know that I do apply the patches to a private tree, and I just merge them to the official public X.Org tree when the bug becomes public, and then only after that, the people who build the binary packages for OpenBSD build them from what was committed to CVS. But for other projects, I don't know if they wait for the public release to rebuild their packages, or if they start building from a private tree where the patch was already applied.
It's gonna be tough to do with GitLab, I think.
Okay.
Time to make.
Yeah, go ahead.
Time to patch. I was going to suggest patching GitLab, like making an upstream MR for them because open source.
Good luck with that. Not mentioning, because I mean this needs some very deep change in everything. Right now, I'm not even sure that you can open a merge request that would be private. This is something we'd have to check. But having private merge request seems to be pretty much conflicting with the way the merge request is exposed by GitLab right now. Right now, whenever you open a merge request, the branch gets actually included in the main tree, in the master tree, in the origin tree. And whenever if you just pull the origin tree, you're able to look at all of the merge requests that are there. So basically, if you create private merge requests, I'm not sure you would be able to have those finite grain access, so that's going to be a little bit complex to do. We are starting to use GitLab internally at Red Hat. It's not news. I think we already advertised that in Linux Plumber, or at least we will explain that next week in Linux Plumber. For all of those CVEs, what we're going to have is we're going to have some separate private trees on GitLab that would have all of the people that needs, I mean, for the very embargoed one, the one that where only people need to know, like Spectre and Meltdown, we would create a special tree for them, include all of the people that needs to have access to that, and then we would basically create a merge request or directly merge the result into the main tree when it goes public. So that's not so much different to what we are doing right now with a private branch, with a private tree. But I don't think GitLab would solve all of these there. We can always request them to do this kind of stuff, but it seems like it's very much the low-level part of GitLab are very not toward this goal.
Okay, so we would need to maintain a separate project for the repositories with security issues and work there, and just create the network request when it goes public.
I think that would be the easiest. That would be the thing that you can do right now. So yeah, you create a like either under free desktop or we can create a group like X.Org security board. You can clone every project you want there. You can include the merge request for the CVE. You can have a discussion with the people involved in there, and then you can release the tree there. When you can release, you can
Yes.
publish the merge request.
And then the issue is to figure out how to move private issues from the main repository to this repository.
Yeah, you can do that really easily with GitLab. You can move the issues, so that's that's one way of doing it.
Okay, nice. Then. So yes, then we will just need to prod the vendors present on X.Org security to check with them if this way of preparing the patches would fit their current workflow.
Yeah, and what I would even suggest, if you have if you have the regular CVEs, that the ones like there is a buffer overflow and this kind of stuff, well, you can just use one generic project. But if you have one very kind of not difficult, but the ones that do not need to get out of a handful of people, you just create a specific project for that particular CVE that you name it like, I don't know, XKB dash CVE dash something. You can open to how many people you want. Like, for instance, if you want to share the patch with Red Hat or with SUSE with OpenBSD, you can open those people, you can invite them to be part of this project so they would have access to just this particular bug. But whenever the CVE is done, then you just kill the project, and those people won't have access to this anymore.
Yes, that's nice too. Okay, so still we have some ideas on how to move forward, and maybe at some point we will see if it's possible to move the, because currently one of the things that I'm a bit worried about is that all the traditional X server and libraries report to go to the X.Org security mailing list. Because as I said yesterday, we never see any issues concerning Wayland, the library, Western, WA root, and so on. Are there no issues, or are they just handled somewhere else?
I can actually speak to that one.
Yep.
I found two vulnerabilities in libwayland server recently. They're both still embargoed, so I'm not going to mention what they are, but I will say that I filed them both as confidential issues on GitLab because I couldn't think of a better place to do that.
Okay, so they are handled directly by the maintainers.
I assume so. As I said, I did that because there was not an obvious security. There wasn't any sort of information as to what else to do. But I think like that was the best idea I could come up with at the time, because there wasn't any sort of information that said, please send security issues to X.
Yeah, they should have something like that. But yeah, we knew something was going on because we knew something was going on because the Wayland developers asked us how to get a CVE ID assigned. But yeah, X.Org security doesn't know the details, just that they have a CVE ID.
Yeah, that just sorry.
Like if such things should instead be sent to X.Org security, I guess the answer is that needs to be documented in the Wayland, in like a security.md file or something in the Wayland repos.
Yeah, first we need to agree with the maintainers of the various Wayland library. And this makes me realize that I forgot to regenerate my slide with the topics, because one topic that I added just before starting the workshop is that is the documentation topic. We need to update the wiki about the procedures. And maybe, and also, for example, in the procedure that is documented in the wiki, we update the wiki whenever an advisory is produced. But I don't know who is still able to edit the old wiki. Alan and myself, for sure, we are able to do that. But I don't know about any new maintainers, even the current X server maintainer. I'm not sure if he has access to the wiki. And so,
are you talking about the general X.Org wiki, or
yes,
the specific one for the?
No, the general X.Org wiki.
So everybody who still has SSH access to the old server should be able to have the wiki there. The one thing that the Nouveau project did previously was to migrate their wiki that was hosted on X.Org, I think, to a GitLab Pages environment, which allow everybody to contribute with merge requests and all this kind of stuff way more easily. So maybe that's something you can actually bootstrap or request us to do. And the idea is just that we would host the wiki instead of using the old wiki or whatever it is as a GitLab page.
Yes, I think this is already noted somewhere. That's on a to-do list.
Maybe.
I don't know since when.
But certainly if we're setting up an X.Org security group in GitLab for this, we should be able to have a wiki sub-project under there. Or a wiki replacement GitLab Pages sub-project.
Yeah, and you can even have we can very easily create a DNS entry like security.x.org or something like that, or security.freestyle.org that would point at your wiki. So that would be very easy to do.
Also, I think there's a dot well known for security contacts.
Yeah. I'm not sure how widely it's used, but yes, that does exist.
Right. And given how poorly we're doing at keeping up with just the X.Org security issues, I'm not sure if we want to take on Wayland and everything else on freedesktop.org, but we should certainly encourage them to document how security issues should be reported to those projects, so people don't have to guess.
Yeah, I don't want to have to handle all those. It's just that it should be documented how they are handled, and to make sure that all the maintainers have a few IDs and have the pointer to the list of the checklist of what needs to be done whenever a security issue is reported. If they already know all of this because they are also maintaining other projects, then it's perfectly fine. But if they are newcomers and need some assistance, and then we can help them a bit with that. We have a number of documents already written. So I think we basically covered all the topics that I had in mind. I don't know if someone wants to add something or.
I think for Rust, I think given the general state of X and how the odds of making huge, very large changes to X are very low. I mean, using Rust in X would be great, but I also think that would also be a very large change, and I don't really see it happening with the current amount of labor. I think something that'd be more likely to be viable would be using Rust in Wayland compositors. And I'm thinking specifically in either libwayland server or especially like WL roots, because that seems to be where it seems that most compositors are using WL roots as their underlying library.
Yes, that's probably more likely to happen in the next future. I was mentioning Rust in the Xcode as a possible way, perhaps, to attract new people, saying, well, here there is an existing code base that would be fun to convert to Rust. If you want to help, welcome. And and see what comes out of this. Most of the system that I know should be able to use some Rust at some point. Yesterday, I heard that Lisa is considering starting using Rust. So, for example, for OpenBSD, this will cause some issues. But if we fix the, if we manage to either get Rust in base or have or move the Xenokara to port, then the issue is fixed. And moving Xenokara in ports is something that I'm considering for some times now. I have some working prototypes, so it's not really complicated.
I was going to say, I'd love to see Rust and OpenBSD base, but that's completely off topic.
Well, yes, someone that's private, but there are some people who have made some demonstration that it's not that difficult, even in the kernel.
But certainly as Firefox and GNOME already require Rust, if you are actually running an X desktop, you probably already have some support for it.
Yeah,
LibRSVG requires it, and
Right.
Yes.
most everything requires LibRSVG. And
SVG is still able to build the old C code when Rust is not available, but yes, in most of the systems and on most of the architectures, we already have a full Rust support. Just RISC-V is not yet ready.
I mean, I'd love to see Rust and libxml2. Not least because that would require its use in. That would make Rust a dependency of DNF, and I want to see Rust in DNF for other reasons. But anyway, that's again totally off topic. So I think Rust in X would, like, Rustifying X. I think it would be an interesting project, but I also think that it might very well take away time that could be better spent on deprecating X and transitioning projects away from it.
Yes, that's a trade-off.
Because I think ultimately X needs to at some point be officially deprecated, like X11.
Yes, we can say that there is no more new development, but and the support for X11 is still going to run for a number of years, just because companies like Red Hat have some contractual needs to support X for the next, I don't know how many years, as part of the currency.
Right. The problem isn't when all the desktops are fully Wayland, it's when everybody's custom applications that they've been running for 20 years internally are all converted.
Hence why I was thinking of the sandboxed X Wayland kind of thing, or isolated X. Like if somehow X Wayland could be made a sidecar of some sort, so that it's ideally, perhaps this is really far off, but maybe it could even be embedded into XCB and or XLib. That would be a totally weird idea, but
well, I think there were some projects like that where they got rid of the client server part and try to build X application that were directly running, but I don't remember if it was for Android or what. It was far from complete, of course.
Yeah.
Because the hard part there is the DRI. Currently, there there are two protocols in every X application: the X11 socket and the DRI.
There's also the issue that X clients expect information that Wayland simply does not provide.
Well, anyways, I think we will try to write down some small projects for the Summer of Code or the X.Org coding projects, which I forgot the name of the evoke. Well, I remember evoke, but I don't remember what it means. Projects, so that if there are students somewhere who would like to play with rewriting parts of X in Rust, they can play with that. The XCB project started a bit like that. It was some university project that ended up being included in the main X code.
Yeah, unfortunately, I think we've had the converting the server-side XCB in the project ideas list for a decade, and no one's ever jumped on it.
This is why I was thinking that maybe adding some Rust on top of it would attract new people.
Yeah.
So I think we are done for this workshop. Again, unless someone wants to add something, we still have some time if there are more topics to discuss. But what I had in mind, we've mainly discussed what I wanted to discuss. I'm a bit sad that there was no more participation, but I was somehow expecting that. Thanks everyone for coming.
Okay. Then that's all for today's workshops. Matthew and everyone who was here today, thanks for coming. And see you next year.
See you.
Bye.
Bye. See you.